Okay, for this video, I want to do an example of turning an arbitrary problem into augmented form. And so we've got a problem here. It's not even in standard form, and it's got some extra weird things going on. And so I want to introduce two tricks, and then also show you how to turn this into augmented form. So most of the time when we're dealing with standard and augmented form, our variables are constrained to be non-negative. Most actual solvers sort of assume that we've got zero as the lower bound for all of our variables. And the way we'll run simplex method will assume that we have zero as the lower bound for our variables. If that's not the case, then we need to do something. And so here's the trick. There's two potential ways that that could go wrong. One is if we get a variable that's constrained to be non-positive, less than or equal zero, then we can essentially flip the variable by replacing that variable with its negative twin, if you want to think of it that way. And its negative twin will then always be greater than or equal to zero. Okay. The other thing that we could end up with is having a variable that is unrestricted, or a free variable where it has no lower bound and no upper bound. If that's the case, we use this special trick where we replace the variable with x plus and x minus. X plus is going to hold the positive amount of that variable, assuming the variable is positive, and x minus will hold the negative amount of that variable if that variable ends up being negative. Both x plus and x minus are constrained to be positive. You'd think that there's maybe some kind of ill-definedness to this procedure, because for example, if you wanted xj to be 5, you could have x plus to be 5 and x minus to be 0, or you could have x plus to be 10 and x minus to be 5, sort of thing. But due to how LPs are solved, only one of those two variables will be non-zero, and the other one will always be 0. And so it's kind of a weird thing to do, but it turns out to work in the case of linear programs, even though we sort of have an x plus and an x minus. Okay, so using these two tricks, as well as the other kind of ways of introducing slack variables, maybe I'll just quick remind us. If we have a less than or equal to constraint, we then add a slack variable to make it into an equality constraint. If we have a greater than or equal to constraint, we subtract a slack variable to turn it into an equality. Okay. So let's go ahead and put this problem here in augmented form. We don't have to touch the objective, so we'll leave the objective alone, but we will modify each of the three constraints. Before we get to the two constraints that we have here, let's actually look at our two variables. First off, we've got x1, which is constrained to be less than or equal to 0. Let's go ahead and replace x1 with negative x1, and we'll give it a star to kind of denote that it's the modified version. I guess because it's going to be the negative version, we could put a minus sign on that. And then x2 is unrestricted, and so we'll replace x2 with the combo of variables x2 plus minus x2 minus. Okay, and so let's just do those replacements into these two constraints and see what we have. So we've got -3 times x1, but we're replacing x1 with negative x1 star plus x2, and we're replacing x2 with x2 plus minus x2 minus. Okay, and that's going to be greater than or equal to -2. So we'll introduce the slack variables in a separate step. We'll do this in a couple steps. Now let's take the second constraint, which is 2x1, 2 times, we're replacing x1 with negative x1 star. And then we have plus 5x2, so 5 times, and always put in parentheses when you're doing this substitution, x2 plus minus x2 minus. I'll put these ones in parentheses up here as well. And that's going to be less than or equal to 1. And that's with, now we've got the variables x1 star, x2 plus, and x2 minus, and all of those are constrained to be greater than or equal to 0. Okay, so we've dealt with our variables having sort of weird bounds to them. Now let's go ahead and introduce our slack variables in order to essentially turn these inequalities into equalities. So I'll take this one and bring it down here. So I'll have -3, I guess, times negative x1 star will give us positive 3 x1 star, plus x2 plus minus x2 minus. And then we've got a greater than or equal to. I'm going to replace my greater than or equal to with a minus. And since it's the first slack variable, I'll call it S1. Your book tends to just add x3 and x4 and x5. I like giving my slack variables a different name and denoting them with an S. So that's my first slack variable, and then it's going to be equal to -2. Let's do the next constraint. So 2 times negative x1 star is going to be -2 x1 star plus 5x2 plus minus 5x2 minus. Now we got a less than or equal to constraint, so we'll do plus. We need to introduce a different slack variable, and so we'll call this one S2. And that will then change our inequality into an equality, and our right-hand side is 1. Okay, and so if I wanted this problem in augmented form, these would be my constraints in augmented form. Notice that my constraints are all equality constraints, and I've got non-negativity for all of my new variables. So this problem is equivalent to the original problem. We're sort of having to use 3 variables to do it, but it gives us an equivalent problem. Actually, we're using 5 variables, right? Because now we've got, in addition to these ones here, we've also got S1 and S2 are now 2 new variables, and they're also both non-negative. So that's it for this video. See you in the next one.